probably your primary function of your power supply, right? Converts alternating current to direct current. Why?
The computer needs direct current.
The computer uses DC, uses direct current. Okay, normal household electrical outlet is using what?
AC.
AC, alternating current. Colin, what's going on? Huh? Okay. All right. So moving forward, what voltage levels do we have coming out of our normal household circuit? 120 typically. When we say 120, what does that really mean? Huh?
It's 110, 115.
It's probably a little less than 120 volts, right? It usually is going to run somewhere in the range of probably about 115 to 120, somewhere in that range, okay? Thereby, you can bring us into a whole nother issue about Ohm's law. How many of you are familiar with Ohm's law? Has anybody ever done anything with Ohm's law? Volts, amps, and watts?
I think I might have once, but I'm not necessarily sure.
Okay. We're going to study that a little bit as we go through here, okay? Because I do want you to understand Ohm's law and be able to actually make some calculations in relation to Ohm's law, because you are going to need to understand that anyway. When you go into, as a system administrator or a computer repair person, when you go in, Colin, to design a server room or you know, a computer lab or anything else, when you're adding components, aren't you going to need to know what's the purpose of all this stuff? Aren't you going to need to know what these computers are going to be used for? You're going to need to know a lot of this stuff. Are you going to need to know how many computers are going to be in one location? What if you have 30 computers? Are you going to have more than one circuit?
Yes.
Yeah, I'd hope so. Because the wattage requirements that you're going to have on that many computers is going to require more than one circuit, okay? And you're going to have to take in and make some of those calculations, not only from a direct current standpoint as it relates to your computers or your components, but you're also going to have to relate that back to how much of that stuff do I have in one location. Is, you know, what's my server room requirements? Am I going to have one 30 amp circuit? Am I going to have 6 30 amp circuits? Am I going to have, you know, several 20 amp circuits? Do we know and understand the difference between the 30 amp and the 20 amp circuit? 10 amps obviously is the difference, but what does that mean? We're gonna talk about that a little bit when we get into Ohm's law, because there is a definite difference. And what do you think? Why do you think there is a definite difference? Why would I increase amperage from 20 amp circuit to a 30 amp circuit?
So you get
More voltage.
Probably has something to do with the amount of stuff I have on the other end, right? The wattage requirements or the voltage or amperage requirements, right? If I have so much stuff on the other end, how much volts do I have coming? We just said 120, right? Well, if that stays constant and I add a whole bunch of stuff to the other end, what's going to increase?
the voltage.
Well, when we talk about Ohm's law, you're going to learn that the amperage is what's going to increase. As wattage increases and voltage stays consistent, it's the amperage that's going to increase. Well, as the amperage increases, if I have 20 amps, I got too much stuff there, what's going to happen to that 20 amp circuit? If it starts trying to draw 25 or 30 amps,
It's gonna blow
it's going to trip that breaker, right? Why is that breaker tripped?
because there's too much amperage.
But why do we want that breaker to trip? What is that breaker? It
protects it from.
It's a protection. It's a safety issue, right? What is it actually protecting?
The computer.
It protects it from completely blowing.
It protects the. What's that current flowing on? usually some kind of copper wire, right? Well, copper wire is rated in according to the amperage and the usage that it's going to be used for too, right? Okay, so there's lots of factors that go into that, but you've got to understand how that whole mix of Ohm's law works, okay? The components that go into your PC are going to draw a certain amount of wattage. So you're going to have to buy the right kind of power supply to meet your PC's requirements. That make sense? Okay. So, as we said here earlier, 120 volt power from the wall outlet to DC voltage levels. It is an AC to DC conversion process that power supply goes through for your computer. Okay? Something else that it does that doesn't get mentioned much here is what voltage levels do we deal with in our computer? Low voltage levels, right? We don't deal with 120 volts, do we? So that power supply also is taking 120 volts and bringing it down to voltage levels that are acceptable for what we're trying to accomplish in the PC, which typically runs from plus or minus 3, plus or minus 5, plus or minus 12, ranges like that, okay? Sometimes even lower when it comes to the power supply, or not the power supply, but the CPU like we talked about last week, right? Okay, so why is it important to you? Well, for one, you're going to have to be able to understand and troubleshooting the computers, right? So you need to be able to use a voltmeter, okay, or a multimeter, okay, because a multimeter is going to give you the ability to test volts, it's going to give you the ability to test amperage or ohms, and it's going to, and you can also test, well, the resistance I think is in ohms. So we'll go through some labs where you can learn to use a multimeter, okay? And I think even the power supply, you can test continuity too, okay? But the PowerPoint's also going to show you some of those tests, so we'll wait till we get to that point. Upgrades. You know, why would I have to do a power supply upgrade? What would be something that might require me to have to do a power supply upgrade?
You could get more. That's what I'm looking for.
You put more stuff on it?
Maybe I'm changing the makeup of my PC. Why? What would be something that might require a change in the makeup of my PC?
CPU? CPU?
CPU is probably not going to be something that's going to require a power supply upgrade. Give me something else.
Motherboard? No.
Probably not. When I make an upgrade to a PC, let's throw memory aside, okay, and performance aside, so we're not talking about the motherboard and the CPU and memory. What other things would I maybe upgrade in my computer?
CD drive, DVD drive.
Usually it's going to associate with some kind of increased capabilities, okay? Well, one thing that jumps out is an increase in today's resource-intensive applications, like gaming and stuff like that, is video, okay? Well, a lot of times when we upgrade video to handle some of these games and things that we can deal with, just like in our lab, we do game design, right? Well, we do a lot of high-end 3D graphics and animation stuff, right? Well, in order for us to do that and handle the load of the resources in those applications and the graphics, the OpenGL graphics and things like that are very high-end, we had to upgrade our video card that increased memory and processing capabilities for the video. Well, in order to do that, guess what else we had to upgrade?
Power supply.
Power supply. Why do you think we had to upgrade the power supply along with it? What do you think that video card was going to require?
More energy.
More power. Okay, so we had to match what our power requirements were with the equipment that was going into it. Does that make sense?
Mm-hmm.
So you got to understand that. So what you have to do is understand how to properly perform that upgrade, and anytime we do those